Bismillahirrahmanirrahim. Allahumma salli wa sallim ala Sayyidina Muhammad. In the name of Allah, the All-Merciful, the Most Merciful. So in today's video we are going to cover the capacities, and I decided to cut them into two sections, with one section that we cover after ayah and beliefs, because they are more subtle, as we'll see inshallah. So capacities are defined as the events that are directly in the control of an agent, that is to say he can choose to make them happen or not without being restricted by another agent or by a nature's behavioral law. So that's the full control side of life, as opposed to the pleasure and pain, which is the full feeling side of life. So they have two general properties here. We can notice that there is a high variability across people, within a family, within a nation. There are disabilities, and it also change according to the situation, to how you are used to doing something, to the time of the day, and so on. And the second property is the cause here. As we'll see, the cause, we stop in the chain of causality, we stop at people when somebody is doing it, and that's the ultimate cause we will be looking for everything, as we'll see later. And here the cause is easy, it's the executing agent, but we may still not know what is the associated intent behind the execution of a capacity. Just as a note, in order to prepare things for later, for all that we're going to cover, all the judgments, all the interpretation of nature, here it is very important to organize them in a way that makes sense. And just to remind you, the four criteria I use: meaningful, comprehensive, applicable, simple. There's also usually, to understand things well, to structure things, there's usually a fifth criteria, which is mutually exclusive. I like to have concepts that do not interfere, that do not cover the same thing twice. Here for life it will be it's not doable. There are topics that are covered multiple times in different categories. Even though you scan them twice, it will still it's unavoidable, because of the complexity of life, and all the perspective matters. And that's these four perspectives that I decided to choose: body and soul capacities, extended nature, that is to say nature and all that humans do with it, pleasure and pain capacities. Here it's a specific focus on relationship between people's actions and pleasure and pain. And same for ayah, and these two will be covered after this chapter on ayah and beliefs, and in this video we cover the first ones. So there they are, all the human capacities. Basically every human actions come from one of these boxes, and we're going to cover them in order. The first one is body and soul, and I have identified 6 of them. Soul is, for now you can call it consciousness, or the way you want it. It's just this, we still don't know exactly where these capacities are located, and for now we just put everything into these two categories. So we're going to cover them now: freedom, perception, movement, pressure, communication, memory, and reasoning. So freedom, so it's the ability to make intents, that is to say, to set an event as a target for one's life. You can set a target to climb the Everest, to cycle at work, you can reject coercive law inside yourself, even though you apply that law, you are forced to apply that law by, I don't know, a dictator or any coercive force. So here it's what is in your head, true reason for which you do things, and you have full power on this. However, this capacity have a few limits. You can make one intent at a time and one intent every few seconds, and for more complex decision it makes sense to take way longer. Also a bit more subtle, the intents are limited to the range of your imagination, or basically all the historical situations you've been through and the combination of them, and by combination it can be any element of any situation that can be combined together. This still applies as your range of all these combination defines the range of imagination, and your intents can only come from this range. You can't expect a person to typically understand a system that he's never seen, he's never heard of. And the fourth limit is a bit more subtle. Intent, not all intents are equivalent. Some intents are more effective or more efficient, and those criteria are limited to the knowledge, to the understanding, to the problem-solving capacity of the person. And all these terms will be seen in the appropriate categories in this life model. There are also special cases when you are a small child, intents not sure what exactly, how free is exactly a kid. As we all of us, we don't even remember those first years. We don't exactly know if we were free or not. There are specific mental diseases that may question this capacity, that may undermine it. And also late age can lead to special conditions where this freedom may be undermined. So that's the first capacity. Second is perception, consideration. I would have loved to make all kind of drawings, all kind of charts that better explain all these elements, but it's not the core value of this channel. So you can find, if you want to understand the underlying mechanic and of how things works for all the senses, you can check other videos on YouTube. But for me, I will just cover the main limits. So here, vision first. So all things related to the eyes, it's good to see. However, we have some limits. There are limits in the light frequencies below infrared or above ultraviolet. We are limited. We don't see. There are some animals that can, and that's one limit of our eyes. Same for the light intensity. You can't look at the sun directly, especially during an eclipse. Otherwise, that may be the last thing you see in your life. Next is the size of object below zero, typically 0.1 millimeter. You cannot discern anymore what's happening, so you are limited here. And there are things happening below 0.1 millimeter. But to be able to see them, you're gonna have to use another capacity, which is a system capacity defined below. The eyes are limited in your range of view is also limited. There is this central and peripheral vision also. So these limits can be basically identified by the maximum angles, horizontal, typically 120 degrees horizontal and 90 degrees vertically. Then hearing, same here, there is a minimum and max sound frequency. Just for information, sound is a vibration of the air molecules, and according to how fast they vibrate, you can or cannot hear it. Same sound intensity, above certain level of decibels, it will cause damages to your ears. And below a certain level, you don't even hear it. The animals that walk, the very small microscopic animals that walk on your skin right now, they make noise, but you don't hear it because you don't have the hearing range is limited. Then comes smelling. So it's all that is related to the nose and the interaction between aromatic molecules and the sensors in the nose. Here you need to have a minimum quantity of these active molecules to be able to smell them, and it's a very limited accuracy there is a very limited accuracy in identification and quantification of flavors, in particular if you have multiple flavors present. You can't smell toxic molecules and all other conditions, all other extreme conditions, high temperature and so on, and you can't use smelling for a dedicated task for too long, especially when you don't take the oxygen as it is required for the body to function. Then comes tasting. Same here, it's very similar sensor as the nose. It's just located on in the mouth. Same here, very limited accuracy in identification and quantification of flavors, limited to mouth touchable molecules, and you can't taste specific task for too long, as you have to eat, otherwise you won't be able to do it anymore. Touching, so here there's a minimum maximum pressure force of contact. Same here, if you get hit by a truck on the street, yeah, you can feel it, but that's the last thing you can feel. And same in the minimum side, some same animals we mentioned before, they apply force on your skin, but you don't hear them, you don't feel them, because it's below a certain threshold. If you take two needles and you put them on your skin and you get them progressively closer and closer, at some point you won't feel like there is two needles, you will only feel one. That's another limit of touch. There's also again, quantification is a big limit of the body. It's very hard to quantify based on body senses, to kind of identify exactly how much, to put a number on this force that is applied on you. And finally, limited to touchable material, same as well. Temperature and pressure, when you go outside, you know when it's cold, you know when it's hot. It's because there are sensors here as well, and there's a minimum maximum temperature that you can feel. Also, if the temperature change, the change depending of how fast it goes, you may or may not detect it. And quantification limitation again. There's also a sensor in the head for balance. It's this this liquid that interacts with the hair cells, and that sends signals to the brain. Here again, limited accuracy in quantification. You can't exactly. Right now, I can tell you my head is approximately 0 degrees to the vertical, but the exact number is a bit more. It's not exactly 0.001 degrees, and to get that number, it's not possible with this sensor. Same, if I move too fast, this sensor will be disrupted. You can typically think of, if you take somebody, make him turn on himself very fast, and then you release him, he won't be able to walk straight as things are disrupted, and it's only tracking the head. There's also an inner feeling here. It's sometimes that something's happening inside your body. At some organs, there is some noise, some weird vibration, all this. It's actually a sensor that is very limited in accuracy. We don't exactly know. It's hardly, even the signal itself is hard to interpret. Sorry. And finally, body positioning. Somehow you know where each of your limbs is. That's this sensor here as well. So that's all the senses we have, and here the capacity is called perception consideration, as all the sensors are working all the time. It's just us that will decide whether to consider the signal they are providing or not. Like when you close your eyes, you still receive light in your eyes, but you decided to ignore it. And there are special cases against various diseases that can target a specific sense, injuries, permanent disabilities, early childhood and late age also. A lot of things are happening. So that's for perception consideration. Then comes movement and pressure. So it's the ability to move body parts and apply pressure by activating muscles. Pressure is actually very related. These two. Pressure is just that you've met an obstacle, so you can't move and you can't move anymore, but it applies a force on the obstacle. So all the limbs movement, or grabbing object, excretion or viewing delay, you are contracting muscles here. Heavy breathing, pushing the door, moving the tongue, but not the speech. The speech is covered by something else, by another capacity. But moving the tongue is basically you contract muscles as well. And there are plenty of limits here for the movements. And if you want numbers, you can check the Olympics performance, the world records. So limited range of acceleration, speed, trajectories, positions, limited range of force and stress here. Check weightlifting. Limited volume and surface shapes of an object. Also here check climbing, all these various walls that we can or cannot interact with. We have a relatively higher control with solid materials, but with liquids and gases it's very hard to apply this force. Liquids, we can still use gravity to kind of work out a way to move that liquid, to put it under pressure. However, gases, we are limited. We are very limited here. Required, yes, we all these capacities, and also the previous ones, they require the whole body to be in working condition. Of course, have enough water, enough food, enough sleep to be able to apply them. That's another limit worth to mention. And then finally, pressure since it's the same sensors. It's the same as the touching sense. You are limited to touchable molecules, and here again, many special cases, disabilities, paraplegia, tetraplegia, many disease, early childhood and late age. A lot of things are happening as well. And then comes communication. This one is a bit more subtle before defining it. We need to define the word message. The message is the definition I will use all across this channel. A message is an event representation by an agent. When we live our life, we do not. When we live our life, we do not interact with other people by sending each other events. We use a way how to say it. We represent things in a way that is communicable between agents, and to do that, there's two steps. We encode a message. We turn an event, typically a house. When I see a house in front of me, I will give it a name. A name typically is a representation, and this representation in my head, I will have this representation of a house that I can share with you. And when I tell you, I have a house, you will in your head decode that message, hear the word house and think about the actual event, and you will have in your mind a house as well. And the house I had in my mind before is not necessarily the same as the house you have, and this is all the challenge of this capacity, which is communication. And communication is the ability to encode and decode messages between living agent. So here we include everything that has a meaning to it, that has a representation to it. So it includes speech, writing, drawing, reading, and non-verbal clues. Just body gestures, voice tone, eye contact. You can already guess from these clues, even if it's just a movement, you can already guess something about the person. When you guess something, it's a message, it's a communication. And it also may include the use of nature elements, even though they are covered in another capacity. When it comes to symbols, when it comes to representations that goes from one agent to another, that's classified as communication capacity. So here, as examples, the words I'm sharing with you right now are this slide. So this slide is using a nature element, a system, a computer. But the content of it is something I looked at the world, I represented it by some words that I share with you, and you hear those words and try to project them to your world. So that's typically this capacity, and there are a lot of limits. As you can guess, we need to agree upon a decoding representation between the involved agents, otherwise there will be interpretation challenges here. And so here is basically the language, the proper use of we are born and grew up in a place where we are taught a language that allows us to have that agreement, but language has its limits, as you know. We are also limited in the word's quantity, whether by memory or time, and debit, how fast we can speak typically. The drawings are limited in accuracy, same for gestures. We are limited in accuracy, limited in number as well. There may be uncontrollable interference. For example, if I move my hand to get rid of a mosquito, it can be misunderstood as a salutation wave to somebody, and these require a disambiguation to be figured out. So these may interfere and prevent the true message to be shared between two agents. There is also a limit in the representation accuracy. So that's here the difference between what we truly want to say and what we say. So if I, for example, misunderstand a word and use that word to say something, you will misunderstand it because I misunderstand it at first. So that's this limitation here, and there is a bit more subtle limit, which is limited representation power, which is here the difference between the event that we talk about and how we represent it. So when we use a word, we are discarding a lot of information on the true event, and this is represented by this limit. And same here, there are special cases, disabilities, diseases, early childhood and late ages. A lot of things are happening as well. Kid starts talking from certain age. Then comes next one, memory. So here, ability to remember and recall previous events. So basic example, when you need to remember the first name of somebody you've just met, and for some worship in Islam, you need to remember some sections of the Quran. That's what we call memory here, and you have a lot of limits as well. As you know, max memory volume, can't remember too much. You can't remember too fast. The memorization may depend on the diversity of events you're trying to remember. Memory modification may also happen with time, and there are also a big limit. And finally, recalling a given memory may be done only when hearing a first clue. What I refer to here is, for example, you can try and remember every moment of your childhood, everything you remember about your childhood or a special period of your childhood, and then try to do really everything you can, all the memories you have, and then you travel to the place where you lived. You see the people you've talked to when you were a kid, the places you've been, all all these events will make you remember new memories, and this is the limit I'm referring to here. Some of them are some memories are only, you can only come back to them either by chance in the future, but that you don't control, so it's not a capacity, or by getting there and having a first clue, to being exposed to something that makes you remind of that memory. So that's this limit here. In special cases, same here, disability, disease, early childhood and late age. Just as a note, forgetting is not a capacity. We don't decide this one, it just happens. And finally, reasoning. So here it's ability to build relationships between events, and pragmatically it allows a person to face any situation with a response. So when you are faced in a situation when you want to buy bread, how much does three pieces of bread cost? You gotta add the various information, the prices, the count, the sum, and connect that together in the right way to get your answer. Same, who ate my cake in the fridge? You start the investigation. Who was here? Who knew about it, and so on. So here you have to connect a lot of information, and this is this capacity called reasoning. It has also its limits. You have a limited number of elements you can consider at once, limited processing time, a limited explorable space of possible relationships, since you are limited in your life, limited in processing time, and there is a lot of things out there in nature. You can't do everything, so you're gonna have to find a way. There's also limit, same as the other. Forgot to put it, limits in efficiency, effectiveness, but that's for later. There are plenty of special cases here as well: disability, disease, early childhood and late age. With these body and soul capacities, we already cover most of what we can do. We are exposed to many external things that can be leveraged to do things, and this is covered by the extended nature capacity. And this got in three steps: nature, resources, systems, and processes. So just extend the rationale behind this cut. So the access to natural resources, so it refers to the capacities not designed by human, so it includes all living elements. The access to a system is something designed by human, but to use it you don't need a human, you don't need an extra human to help. And the process is you need a human to help. Just to clarify, if it's system and process seems to be very close, but there's a big difference. And the difference is, do I need to deal with another human? If no, it's a system capacity, otherwise it's a process capacity. Just to give an example, if you have a car, you just put the keys in the contact, and if everything is working properly, you can go move and live your life. So that's a capacity. So that's a system, sorry. However, if you have a car and a driver, that's where it's not just about it's not about the keys anymore. It's about is the driver qualified? You need to ask yourself, is the driver qualified? Is he available? And plenty of other questions. If one day he comes and he has a sad face, then does that undermine his capacity to drive? So it's way more complicated. Even though you have you don't need to do anything except sit in the car, but with the car and the driver, it's way more complicated. And the difference basically is a process has the complexity of at least one human life model, while the system is just natural laws that has been leveraged to natural laws and natural resources that has been leveraged to do your thing. So you don't need to deal with any human, and it's a very, very, very extensive difference, as we'll see. So first capacity, natural resource capacity. So here it's the ability to access and use non-human designed modified nature events such as materials, energy transfers, so including interactions to have access, for example, to running river. That's typically a powerful capacity. Living elements or living byproducts. So examples: water, plants and animals, energy, oil, gas, coal, biomass, and so on, and other natural elements, as we'll see in the nature section of this channel. So this capacity has a lot of limits as well. Some elements may be inaccessible due to environment, location, anything underground, deep forest, underwater, and so on. Not everything is necessarily valuable to humans. Don't do much with sand, with a desert sand typically. It may require specific weather, soil and feeding conditions. So this requires things to do to be able to get the value from it. Some elements are complex and they are hard to assess or hard to make robust enough for yielding a value to your life. And there are also some incontrollable risks such as pests or extreme weather. That's the first one. So it's quite extensive, but the principle is the same. Then comes the system capacity, but before we go to it, I believe it's a good thing to go over examples. So here I listed 5 systems: a bat, a barrier, a blender, a bag, and a street light. The bat here may not be clear, but let's assume it's made from wood. So from the same natural resource, wood stick, you can get a barrier and a bat, but the systems are different, and the systems is rather defined by a function. So here the bat will allow you to strike an object, while the barrier will prevent the passage of a foreign agent or object. So a system has typically a few attributes. It may include some inputs, so projectile, object, application of force to this bat to be able to use it, and outputs. So here you get something in return. So that is the inputs and outputs are defined according to the function. The function is defining the scope of what is included in the system. And finally, anything that is not input output may still be interfering in the interfering environment if it has an impact on how the system is used. Typically wind temperature, here for the bat, wind temperature, obstacle between projectile and batter. So these attributes are usually are common for all systems. So let's go over other examples. Just for example, the barrier, you don't need to do anything here, no inputs, no outputs, you just put the thing and it's operational. But the environment may do things typically that you don't want. Foreign agent object may strike the barrier or break it, and so on. The rain may accelerate the damages to the barrier. Wind, insects may eat or break the wood, and so on. Then comes, for example, blender. So its function is to mix and emulsify food, and inputs now start to have a source of energy, electricity, and of course the food you want to mix, and as the output you get emulsified food. In the environment, the kitchen equipment, the dust, the insects, you need to pay attention to them if you want to avoid any trouble. Then comes the bag. Here the function is to allow a person to carry multiple objects and optionally on the shoulder, so there may be options on the function. Same system may be used differently. So here you can arrange the objects inside, remove them, and say similar environment. Finally comes street light. So here it allows to light the street, same source of energy, some kind of switch somewhere where you can put it on and off, and you get the light in output. So input output may be an event, so it may be anything. And here the interesting thing is that the environment is now interfering when it's during the day. You will see that the street light will switch off, so you can guess that there's something in it that will sense and adapt to the environment to work differently, to deliver the function differently. You don't need to light the street at night during the day, so the function is still reached. And even environment has always some limits, hidden limits. For example, wind. If you get a wind, I don't know, 200 kilometers per hour, the street light won't be designed for it, and it will break. It will be kind of uprooted, and it will break. So the limits of the environment are also important to consider in systems. How do you represent them? I will give you a last example. As it hides a same system. A system can hide other subtleties. Let's take the example of a phone. So a phone, its function is to run mobile application. It takes as input here on the left. So that's a typical representation for a system. On the left is a user input, touch screen interactions, the buttons, the push or the movement of your phone also. It takes also electricity during the time you charge it. And then as output you get various visual displays, sounds and vibration that your body will make sense of, that your communication capacity will make sense of, to whatever you do in your life. And of course you have an environment that may interfere with the phone, the water, dust, food dust, dirt that may it may break the electronics inside, and you may also have shocks by falling that you need to deal with, especially when you have sensitive parts inside the phone. So this representation hides a lot of things. The phone is doing a lot of things, yet you don't see it in this representation. To be able to know more, you can zoom in and try and figure out what you have inside. So basically, if we open the phone, you will have more detail about what happens behind. And I'll give you just an example here. It's a simple example just to show you some feature of systems. So here the same user input is here. For example, let's say you want to take a picture. So on your touch screen you push the button to take the picture, so it will be detected by a subsystem, which is the screen, which is the system itself, and its function is to detect any interaction with the screen. So where you put what kind of interaction, if you brush, if you push, and where do you do it on the screen. And here it will tell as output that the location of the button was pushed. It sends this to the CPU, which is basically the calculation area of the phone, that will say that will identify the location, the interaction as the camera, as the camera application, and a call for the function to take a picture. So this CPU will understand that and send a message to the camera, which is another system again, that will take a picture as input, a signal that is take a picture as input, and it will capture the light it receives at that moment and turn it into a digital format that is sent back to the CPU, and the CPU can send it back to the touch screen that displays it to your screen. And here you go, you see the pictures, you see the picture on the screen. Some other functions are a bit more works a bit differently. For example, if the phone slides from your hand, the phone will start to accelerate to the floor, and that acceleration is detected by an accelerometer. So that's where you can guess that something is about to happen. So it will send, this accelerator will detect that acceleration and send a signal to the CPU saying there is an acceleration, and the CPU will connect to any sensitive part, will send a message to any sensitive part that is vulnerable to shocks, to put itself in to protect any to stop working or to protect any vulnerable area. And finally, the last function, the dust, water, food dust, is basically here handled by the frame, where you just put a barrier that prevents any access to the electronics. So it's all the waterproof surfaces, materials of the phone. Here you don't need to do anything. It's just a barrier, like a barrier that we saw above. So why do I show this example? Here the idea is that a system may be made of multiple systems themselves, and exploring the different levels of functions will be important, as we'll see in the hidden part. In particular, we look for energies, we look for different materials, we look for the different forces and interactions that are used. As we'll have an idea of what they are, so it tells about what we are actually doing. That's why it's a good exercise to look around you and see the system and try to represent at least the various functions that are filled. You don't need to know the exact laws of behavior behind, but just the function already is the function, the input-outputs is already very strong, very important information for later. And this applies to any complex systems that you have around you, a car, a plane, or any energy central, or anything you can think of. So the general definition: so a system is a group of nature element delivering a function within a set environment. The environment is always here, and it may take some events as input and may deliver some events as output, and it may also itself be made of multiple subsystems that fills subfunctions. And the system capacity, the one that we target, refers to the ability of a person to access and use such a system. Just to give other examples, as they are, I think, important. For example, laptop, mouse, mousepad, keyboard, phone, tablet, bottle, chair. What I'm doing here basically is listing everything around me. So what I'm trying to say is that you are absolutely surrounded by them. It's everything we do is encapsulated into a system. So to be able to just make sense of your environment it will be fundamental for later, and it also covers some really fundamental role in human groups. Legal records it's a system where you put whatever written note, whatever happened on a written note that can't be modified at will, like memory. Digital archives, so it's the recent equivalent. Houses, clothes, weapons, all these are really critical systems in our life. So here they have limits. Here we call them conditions of use. You need to have the inputs. Inputs must be provided. The environmental limits, as I mentioned, the wind, there are hidden limits. They must not be overstepped. It has to work within the set range it is expected to work. And finally, the system functions must be valid and operational. The term valid, we'll see that later. Basically it has to follow, it must not oppose natural law. Operational, it has like everything must be as designed, as designed. No event will come and interrupt the function itself, for example. So just here as a note, the condition of use of subsystems adds up for the whole system to be usable. So if a system is made of many things, you have to respect every single rule, every single subsystem to make that system work. And for complex systems, just recently, for example, Boeing had some troubles with the door of their planes, like a door, one of the most basic element. While they have like a super complex engine on the plane, it's the door that prevents the plane from being used. So it's really, it may become important, and for us it's more exploration of subsystems that is important. And finally, the classification of as a system hides some subtlety. The maintenance of a system usually requires some very specific skills. If it requires a specific skill of a specific, like it's a person, and the person is a process. Person makes it a process. So the system is a system until it fails, and when it fails, it's a useless thing, and unless you have access to the process to repair it. Just a subtlety. Talking about process, let's cover an example before going to the definition as well. Here, let's take a simple situation. You are ordering a sandwich in a restaurant. The event happens, this order. The cashier listen to the order. The cashier cash in the money, cash in your money, and finally he records the order on the computer. Then the cook that sees the computer screen updating with the order will start cooking it for you. He puts the bread on the table, add ingredients, add the sauce, put sandwich in the sandwich press, put sandwich out of the press, and put sandwich on the table. And then finally the cashier sees the sandwich on the table and takes it, brings it to the client. Sometimes in the same day, the owner will compute the overall costs and revenues of the business, and he will also go to the market and buy vegetables to refill the stocks. So that's a typical sequence of a process. And here a lot of things are happening. You can first see that there's various tasks that are made by different people, and they have different characteristics. For example, 1 to 11 are ordered, while A and B are kind of more free. They not belong to that order, so it's partially ordered. The tasks 6 and 7 may be, for example, reversed. Some people would prefer to have the sauce on the ingredients, while others prefer it on the bread. A is like really freely running. You can put it anywhere. You can do it anytime, but you have to do it, as it ensures that your business is profitable, is viable. And there may also be some more complex relationships. For example, B, you need to buy vegetables. You have to do it sufficiently to ensure that the ingredients are available. So really, it will depend on the stock, and the stock does not evolve directly with the task. Does not change directly with the task at stake. So it's really more like a special occurrence pattern. So that's for the task. There are also people. Here we have a cashier, a cook, an owner, and we assume that the cashier is of the same family as the owner. So here the key element for a process is the motivation of the people. Why would they accept to solve the human life model by spending their time and money, their time and energy typically for this task. So here cashier one, if it's the same family, it's usually family conformist. We take care of the family, and through it you will get some wealth, you get also some other perks, but the main is the family conformism. The cook one can be a hired employee, so he's paid a salary and he accepts for this salary to do this job. So motivation is wealth. Then comes you can also note that some systems are used. So back at them very quick. Computer, table, sandwich press are smoothly integrated into the tasks. And we also talk about resources. You have ingredient inventories to be refilled, business viability to be checked. And ultimately, at the end of the day, this process, the existence of this process there are few values that are delivered, and values, remember, it's the sum of pleasure minus the sum of pain, and these values can be defined as goals. So your hunger is prevented. You didn't have to buy any ingredients, you didn't have to cook anything to touch. You didn't even move that much your hand except to pay. You haven't done much yet. You have a nice sandwich in front of you, so it's pretty nice capacity. And for the cook, he obtains, for the owner, sorry, he obtains, the owner and cook, they obtain wealth. And as for the cashier, he ensures his family bonds and wealth through it as well, and quite many other utility according to the family. So that's one example of a process. And before the definition, we want to have ways to represent this, and here it's as noted, it's plenty of things that occurs. So there are plenty of things plenty of representation you can draw from this. The usual view is the time view. It's usually called, I think, Gantt chart. Is where you have the tasks, the steps, and the order at which they happen. And typically when one task starts after the end of the other, it means it requires the previous one to be finished in order to do it. And some others, like the profitability SA, step A is independent and usually takes more than 5 minutes to be done. That's one view. Other views, you can look at things in terms of space, how to organize the restaurant, kitchen, the counter, the storage, and you can have a bit more hidden dynamic also. For example, if you look at the origin of your ingredients, you can guess the cheese from Netherlands, the tomatoes from Italy, the wheat from Ukraine. I guess recently it may have changed with the history, with current history. The equipment from China. So here we were just looking at a very small restaurant, small basic restaurant, and here we are in China already. There are things happening in the way processes are run, and it's important to be aware of them. There are plenty of other relevant perspectives, of course, financial documents. You can do it, balanced income statement, ownership papers. You can also have the different views on the people. How are their workload distributed? What are their feedback on their work? How do they feel after the end of the day, typically? Also, inventory of equipment and resources for the systems and nature resources as well. For more detail on all these views, you can check project management videos. So on YouTube you will have them. But for us, the important thing is a process may include a complex combination of people, resources, systems, with space and time constraints, and again, exploring the different perspectives will be important in the hidden part. In particular, we're looking at people attributes and their motivations, the regions that are involved in a given process, the values that are exchanged, and of course the system, since the systems use the same system information that we mentioned before. So that's the process. So the main definition is: a process is a group of events involving agents and targeting a goal. It includes tasks, a set of actions, and specifications. They may be more or less defined, or the time located, or any constraints you want. Roles. A role is a group of tasks made by a single agent, and motivations. So here, agreement with the agents based on their human life models consideration. So here it's not just salary, it's also all the risks you take and so on. So just basically solving the human life model of a person so that person agree to do the action. So it's a way more complicated stuff here in the process, and it may also use systems. I put optional, but basically even a paper when you record your actions is already a system. So there is basically always a system in any process, at least one. So the process capacity refers to the ability of a person to access and use such a process. And as examples, fundamental, big examples, the goals. So ensuring a successful family, a successful education, all the schools, all of them are processes. Businesses, government, non-profit, all this are businesses, are processes, sorry. The roles may involve any human capacity. Tasks usually consider various aspects of the life: time, cost, quality, environmental impact, funding, customer relationship, investor relationship, leadership and cooperation, and so on. And the motivations, usually you will find here pleasure and pain, gain of wealth, ego, family conformism, skill acquisition, and so on. And here again there are limits that we call conditions of use. So we need the agreement of people that will fill your roles, and this agreement needs to be standing in time, which is not easy thing. You also have a capacity that is covered later, ayah and belief of role-filling people according to the tasks. That's what you usually call skills and experience for the given tasks a person is expected to do. And of course, since there are systems, the conditions of the systems are again required inputs, environmental limits, and system functions are valid and operational, and the process itself must be valid and operational. So basically no natural behavioral law that will interfere, and everything should work as designed. So that was the process capacities. Now, with all the capacities we've covered already, now we are covering every action that has been made by humans. So if you think about anything, any event in history, you can identify the processes that have been leveraged by people. You can identify the systems at stake, the natural resources. So it's really everything we've done. So in summary, up to now in the channel, we identify the same feeling that we have, that every human have, which are the pain and pleasure. We identified the range of actions, a similar range of actions for everybody, with the same core capacities and same extension options. By extension, I mean, if you look at the system, if somebody designs a system, you can, in most cases, take the system and investigate how it's done and do it yourself. So you typically, normally, should have the capacity to do the same thing. Yet when you look at the world and how things are done, you can observe very large differences. You can observe very large differences across nations and people, even close countries with similar resources. they may choose a very different way of living their life. You have some urban versus countryside lifestyles, people relying on craftsmanship rather than or industries. You have just simply variety of food recipes. Each country has its own food and so on. Different entertainments. All this shows that there is something else going on. It's not just about the feelings. It's not just about the capacities. There is other factors playing, and among these other factors, they do not choose. Here, among other causes, they do not choose the same actions. And the question is, what makes one choose? Sorry, I didn't turn it well, but you get the point. Among other causes, they do not choose the same actions. And what makes one choose an action instead of another? Is their best choice? And this question will be answered in the next section that we cover, which is ayah and belief. And that's where we will, inshallah, investigate what are the factors that play into how we connect pleasure and pain and actions to ultimately decide a specific action and not another. So that's it for today. Wassalamu alaikum.